Hi, this is Math 7, Unit 6, Lesson 21, Combining Like Terms, and we're in Part 2 today. Alright, so let's see how using properties correctly can help us write equivalent expressions. So in this first part, it says select all the statements that are true, be prepared to explain your reasoning. So which ones are true with the different things here? So we have one side where we have a part that 2 is factored out, and we can distribute that through if we choose to. We can see that the 4 minus stays the same, right? That's the same on both sides, no change there. But what's being done is this 2 is being factored to 2 times 3, which is there, and it's still a minus 2, and it's still going to be added to the negative 2 times 7, which becomes negative 2 times 7 there. So what's happening is the 2 times 3 is what's being distributed, and the 2 times 7 is distributed, and the minus sign is keeping with them both. So that's going to be just fine and be a true statement there. On this next one, we have again the 4 on the outside here, and then we can see that I have a negative 2 times a 3, so negative 2 times 3, and then I have also, adding to that, a negative 2 times 7. Now, what happened to the negative 2 times 3? It's right here, and the negative 2 times 7 is right there. So where did that plus sign come from right there? Well, it's okay to say it's adding the negative there, not a problem. We can say that, not a problem. So that one's going to also be true. On this one here, if we were to work out 4 minus 2 times 3 plus 7, and we distribute that out, you'd have 4 minus 2 times 3, so let's write this out, 2 times 3, and then we have minus 2 times 7, minus 2 times 7. Okay, so that's what that looks like that. I could rewrite that as addition, and we can see that this part's the same, that part's the same, but then this part right here is a little different. If I want to make that addition part, it would look like this, 4 minus 2 times 3 plus negative 2 times 7. So that's not going to match, so that's going to be a false statement right there. And our last one here, we have 4 minus 2 times 3 plus 7. Again, we distribute that out. You have a negative 2 times 3, right? And then we have a minus 2 times 7 there. Okay, so that's what it looks like. So far it's a little different here, but they went ahead and put a parenthesis around everything. Well, to do that, what's happening is I'm putting the 2 inside of everything and then keeping this on the outside. So is that okay? Sure it is. If I keep this over here, and it's like if I'm doing this, it's like I'm going to ignore that for now. So I keep the 4 minus, okay, and then we're going to put the rest of it together. So it's 2 times 3 plus 2 times 7. And I can distribute that negative through, and if I do that, I end up with a negative 2.2 times 3 and negative 2 times 7. So this would be okay as well. So interesting, just how parentheses change things around quite a bit. In the second activity, you have 4 different ways of trying to write an expression with fewer terms. Noah worked it out like this, and he worked it out and got that as an answer. Lynn works it out and gets this as an answer. Jada works it out and gets that as an answer. And Andre works it out and gets that as an answer, right? So 4 different people saw things differently and did things in a different order and way, and unfortunately only one of them got it correct. There's lots of good work that's being done throughout it, but there were mistakes made in each one of the problems with the exception of one. So let's take a look and see what happened. Right? These are really your questions on the next slide. The next slide is, do you agree with any of them? And then for each strategy you disagree with, find and describe the errors. So we're going to see who to agree with and where are the errors. So we're answering this all together here. So here is Noah's. He has 8 minus 3 times 4 minus 9x. We see the first difference to move from here to here is that he's doing 8 minus 3, and doing 8 minus 3 is 5. Now the problem with this is just our order of operations. He should have been doing some distributing first. You can't just do 8 minus 3 because this 3 is connected by multiplication to what's in the parentheses there. So that's where his first mistake was made, and so that's going to be his error. Whatever happens after that really doesn't matter because he made one mistake right there, and it's going to be wrong from that point on. When I look at Lynn, Lynn keeps the 8 minus 3, that's all good, and works with what's in the parentheses. So Lynn does 4 minus 9, x and makes that into negative 5x. Well, what's the problem here? The problem is that is a number and this one has a variable. If there's no variable, I can't join them together. It doesn't work that way. They have to either both be whole numbers, right? Or they have to both have that same matching variable. So you can't combine just a number and a number with a variable, a term. It won't work out. Let's see. So for Jada, let's see what Jada is doing here. Jada has 8 minus 3, and then that goes away. Okay, how did it go away? All right, let's see. Jada does 3 times 4, which is 12. Good. We can see Jada is keeping the minus on the outside. And then Jada is 3 times negative 9, which is negative 27x. That's fine there. She decided to keep the negative on the outside. That's okay. And then we can see that in this one, then she starts to distribute the negative. So negative times a 12 makes a negative 12. And a negative times a negative 27 makes a minus negative 27. Okay, so let's see. After that, 8 minus 12, because those don't have variables, is going to be a minus 4. No problem. And when I subtract a negative, that's the same as adding, right? It's going the other way. That becomes a positive 27x. So this one to me looks like it's been done correctly using the distributive property. Andre also says use distributive property. Let's see what he did. He does 3 times 4 for a negative 12. That's good. And a negative 3 times a negative 9, which should be a positive 27x. But instead, he put a negative 27x. So that's the mistake right there in the multiplication part there. So we would say we agree with Jada, right? That's who got it right. And we found the mistakes for the other 3 and where they made their errors, which is just part of math, and you have to go back and check and see where you made a mistake. All right, so let's look at the next section. In section 3, it's called grouping differently. It says Diego is taking a math quiz. There was a question in the quiz that had the expression 8x minus 9 minus 12x plus 5. Diego's teacher told the class there was a typo and the expression was supposed to have one set of parentheses in it. Where could you put the parentheses in that expression to make a new expression that is still equivalent to the original? So basically putting a set of parentheses into the expression where it won't change things, all right? So here's what we have, 8x minus 9 minus 12x plus 5. When I put parentheses in something, it means to work on that first, or it also could possibly mean to have to distribute a negative number around. So one place I could put parentheses would be just simply right here. By putting parentheses right there, it doesn't change the 8x, it's still positive. It doesn't change the negative 9, it's still negative 9. There's nothing on the outside to distribute, so that would be fine. Another thing you could do is you could do 8x minus 9 minus 12x plus 5, and you could just put parentheses around the entire thing, and that changes nothing. So those are 2 options that you could use. I can't do anything else, or else it would change the entire problem, which is what we get to in number 2. So where could you put it to make a new expression? Okay, that is not equivalent. That's our key thing there, not. Watch what happens here. If we do 8x minus 9 minus 12x plus 5. If I was to put a parentheses right here, in doing that, that causes the negative to be distributed from there to there. And if I rewrote that after distributing it, I'd have 8x minus 9 minus 12x minus 5. And so just adding the parentheses changes that plus 5 to a minus 5. And now I have a different expression. So that's one way that can be done. Your task here is to list as many different ways to answer that as you can think of. And so that's just one, and there are lots more that you could think of on your own or with your partner. I'm going to move on to the summary and then on to the homework. So in summary, we would say that combining like terms allows us to write expressions more simply with fewer terms, but it can sometimes be tricky with long expressions, parentheses, and negatives. So be careful, but it's a way of making things easier, more simplistic with fewer terms. It's a good thing, but you just have to be very careful when you do that. Let's pause there and give you a moment to do your homework, and then we'll come back and check it out. All right, here's today's homework. Noah says that 9x minus 2x plus 4x is equivalent to 3x because the subtraction sign tells us to subtract everything that comes after 9x. Elena says 9x minus 2x plus 4x is equivalent to 11x because the subtraction only applies to the 2x. Do you agree with either of them? All right, so the question is about this negative sign, the subtraction sign there. Does the negative apply just the 2x, or does it also stretch over into the 4x area like Noah says? We would probably say we need to agree with Elena. Now the reason we need to agree with Elena is because the subtraction sign is only with that one. If there was a parentheses, then we could agree with Noah, but there's not. So let's say we take the 9x minus 2x plus 4x, and we rewrite this as an addition problem. You would do 9x plus negative 2x plus 4x, and then we can move things around if we chose to, right? We can move that to that, and have 9x plus 4x plus minus 2x. And we do 9 plus 4 is 13, and 13 minus 2 is going to be 11x. So her solution is the correct solution. It's going to work out just fine. But Noah's doing something different because he changes that whole thing fundamentally into a minus 4x. That would work if it was already going to be 9x minus 2x minus 4x, then he'd be correct. But this right here is a positive, so it can't be that way. All right, so we're going to go with Jada. Number 2, identify the error in generating an expression equivalent to that, then correct the error. All right, so what's happening? We have 4 comes before 2x, 2x. All right, negative 1/2 times 10 becomes a minus 5. That seems okay so far, distributing there. And then distributing a negative 1/2 times a negative 4. So that's going to be a negative 1 times a negative 4 over a 2, which becomes a positive 4 over 2, which becomes a 2. So it matches 2x. We're good there. All right, so this row is right. And then what happens here? 4 stays 4, 2x stays 2x, minus 5, 2x. Everything seems to be okay for the most part. No problem there. We just turned it from adding a minus 5 into just plain old subtraction. That's okay. And then we have 4 minus 5, which combined to get you that negative minus 1. But what happened to this 2x and this 2x? Where did those go? Because 2x plus 2x should be 4x, and I don't see that anywhere. So the error happened right here because the person working this problem eliminated the 2x. They probably thought this minus sign goes with everything, but it only goes with the 5. So they need to add that other 2x back in there because they just skipped that part. Number 3. Select all the expressions that are equivalent to 5x minus 15 minus 20x plus 10. All right, and so this is just a crazy little problem here, okay? I could factor out a 5, for example, from all of these. And if I factored out a 5, I would have an x left in that one. I'd have a minus 3 left in that one. I'd have a minus 4 left in that one. And I'd have a plus 2 left in that one. So if I distributed that all the way through, I'd end up with, oh, it should be 4x, sorry. All of that. So that's one way of doing it. I can also rewrite this whole thing as addition and say it's x plus a negative 3 plus a negative 4x and then plus 2. So that works as well. Okay, nothing wrong with that one either. I could then change the order around to put the the x's together. So I could have 5 times x plus a negative 4x to cluster those up a little bit better, plus a negative 3 plus a 2. I could then combine some things together like this. So I have 5 times 1 minus 4 is a minus 3x, and minus 3 plus 2 is minus 1. That works there. I could go back and distribute through again and do 5 times negative 3x is negative 15x, and 5 times negative 1 is negative 5. So these are all different ways of writing that. So now let's come back over here and see what are we working with. In this one, we have a parentheses added. Let's see, if I distribute this, I get a negative 15. That's good. If I distribute here, I get a negative 20x. That's good. And those stay the same, so no problem. Here, We have 5x plus a minus 15, so let's turn this into a plus a minus stays the same. That's okay there. So it's going to work because we're just turning the subtraction points into adding a negative one there. Okay. Here we're taking a 5 out and we have x minus 3 minus 4x, that's a minus there, plus 2, no problem, matches that one right there like we had. Here we take a negative 5 out. We didn't try that one. Let's see if this works here. Okay, if it works, I should get back to this one. If it works, let's distribute and see. Negative 5 times negative x is a positive 5x. Negative 5 times 30 is negative 15. Negative 5 times 4x is negative 20x. And negative 5 times a negative 2 is a positive 10. So that one works. Here we have negative 15x minus 5. Matches right there, so that works. And here we have negative 5 times 3x plus 1. Looks close to that one. Let's see if this works out here. If I do negative 5 times 3x, that's negative 15x, and negative 5 times 1 is negative 5, which still matches that one, so that's going to work. So actually, they all work this time. Okay, number 4. The school marching band has a budget of up to $750 to cover 15 new uniforms and competition fees at total $300. All right, how much can they spend in one uniform? So we know we're going to have 15 new uniforms at some price, plus $300 for the competition fees, and that has to be less than or equal to our budget of $750. So that's our inequality right there. Part B wants us to solve it and describe what this means. Okay, so to solve this, we're going to subtract 300, subtract 300. So that 15x is less than or equal to 450. Divide both sides by 15, so that x is less than or equal to 30. So what does that 30 mean? That means that the price of a uniform, a new uniform cost, needs to be less than or equal to $30 in order to stay in the budget. And that's what the price of that x is going to be there. Less than or equal to $30 to be in budget. All right, number 5. Solve the inequality that represents each story, then interpret what the solution means in the story. Okay, so here's an inequality right here. We have 7 times 9 minus x is greater than or equal to 42. The story says that for every $9 that Elena earns, $9, she gives x dollars to charity. So when we're solving here, we're going to find out how many dollars she gives to charity for every $9 she earns. That's what our x is going to tell us. She does it 7 times a month, and she wants to make sure she keeps at least $42 from this month's earnings. So let's solve this out. To solve this here, we can make this equal to an equation, right? We can say that it's 7 times 9 minus x equals 42. We can divide both sides by 7. So we have 9 minus x equals 6. We can subtract 9 from both sides, so negative x equals negative 3. We can multiply everything by a negative 1 and say that x equals 3. So what is that going to be? That's going to be our boundary. Our boundary is going to be 3, and now we need to decide, is it going to be values that are going to be greater than or equal to 3, or values that are less than or equal to 3? We have to find the direction for our inequality. So we'll plug that back into our equation. So a number less than 3 is 0. I always use 0 here. So let's plug that in. 7 times 9 minus 0, is that greater than or equal to 42? The 0 goes away, so 7 times 9 is 63. 63 is indeed greater than or equal to 42. This is a true statement. So what does that mean? It means that, because that's true, that means that the amount of dollars she needs to give to charity every week, so each time she gets paid 7 times, needs to be less than or equal to $3. So she always needs to give less than or equal to $3 every time to charity for every $9 she makes in order to keep at least $42 from her paycheck. Next one, Lynn buys a candle, and we have our equation here, 9 minus 7x is less than 6. She buys a candle that is 9 inches tall and burns down x inches per minute. She wants to let the candle burn for 7 minutes. So the x represents how many minutes the candle, how far down the candle burns per minute. Okay, she's going to let it run for 7 minutes, and she doesn't want to do it until it's less than 6 inches tall. Okay, So to solve this here, we make it as an equation. So 9, minus 7x is less than or equal to 6. We're going to subtract 9, so negative 7x equals negative 3. Divide by negative 7, x is going to be equal to 3/7. All right, so now to find our direction, we're going to say x is going to be less than 3/7 or x is going to be greater than 3/7 to find out which way our inequality is going to go. So a value less than 3/7 would be 0. So let's do 9 minus 7 times 0. Set it less than 6, just using our original equation inequality right there. So 9 minus nothing is 9. Is 9 less than 6? That is false. So since that's false, this makes that our true statement. X needs to be a value greater than 3/7. Okay, so how many minutes is it needs to burn down to get to 6 inches per minute? It needs to be a little more than 3/7 of an inch every minute is how much it needs to melt down. All right, and number 6, our last one here. A certain shade of blue paint is made by mixing 1.5 quarts of blue with 5 quarts of white. All right, so what is that going to be? That means we're going to have 1.5, so 1.5 of blue plus 5 of white, make the special new shade we're doing, the special shade, and that's a total of 6.5 for what we're trying to create. Now, if you need a total of 16.25 gallons of that shade of paint, how much blue and how much white do you need? Okay, so we're going to set up two different proportions here. Let's look at the blue one first of all. So for blue, we're going to say that we know that it takes 1.5 quarts of blue in order to make 6.5 quarts altogether. And we're going to use that ratio then to say how much blue will it take to make 16.25 gallons is the idea. How much blue is it going to take? So then we cross multiply, and in doing that I end up with 1.5 times 16.25 is equal to 6.5x. So this part here, when I multiply this out, is 24.375 equal to 6.5x. I divide both sides by 6.5 in order to find out that x is equal to 3.75. So that's how many quarts of blue paint I'm going to need to make that work. And actually it's probably more like gallons actually. So a little funky because I went from quarts to gallons, so something could be off in my calculations. The numbers are working, but I'd have to think a little bit more about if something has to change. I know my answer key left at 3.75, but it is interesting that this is quarts, and this is gallons, or quarts, gallons. Something's off a little bit there, but let's leave it like that for now and just pretend that this should be quarts, okay? I'm not going to worry about it. So white here, because that's too many to ask. So white, we have 5 out of 6.5 is equal to something out of 16.25. And again, you're going to cross multiply, and as you do that, you're going to find that x is going to be equal to 12.5. So for the blue, we need 3.75 quarts, perhaps, or gallons, and for the white, we need 12.5. My guess would be it's gallons in order to make the gallon mixture at the end. That's it for today, and we'll see you next time.